Okay. Um, so we should be live, which is excellent. This is a little bit strange for me. It's the first time I've ever done some streaming, but bear with me if there's anything that's inconsistent or not working. This is really for me to hold myself accountable, to do kind of regular routine of work. So this might be a little bit informal. This might just be a bit of a rant. But the thinking that I had was if I turn up on a regular basis to share what I'm doing on a stream, that helps me build a habit of designing and developing the projects that I'm already doing, as well as sharing with you and anyone who's interested my process. So I'm just going to be modeling using Rhino predominantly, sharing what I'm doing, solving the problems as I'm going along, getting annoyed at it, and maybe even sharing some of my thoughts about my designs and to be as pretentious to say my design philosophy. But let's crack on with it. I am currently printing. You can see my 3D printer whirring in the background here. I'm currently printing some components for a turboprop engine model, which my granddad is working on. So this is just some spare parts for a scale model of a turboprop engine. My granddad also has a 3D printer, but my one has a much smaller nozzle size. So with the 0.2 millimeter nozzle size, you can get much greater detail, which for all the little cogs is quite important. But while that's going in the background, what I'm going to be working on is some of storage solution, which not actually working right now. Why am I not seeing Rhino? Aha. So let's get into what I was planning on doing. So for the next hour or so, or until I just get bored of talking to you, I'm going to be working on a storage solution for my 3D printer cupboard. Just to kind of explain a little bit, I need somewhere to store some filament, which is the material that goes into a 3D printer. But I've made this little mock-up where the yellow box is my printer and this yellow plane on top represents a kind of shelf within my cupboard, and there's a free space between the printer and the wall. That doesn't really give you much of a better view. There's a free space between the side of the printer and the wall within the cupboard, but it's not quite big enough to store boxes of filament kind of this way, where I'd be able to stack them like this. So this would be the most kind of volumetrically efficient way of storing filament. But the reason why I can't do this is because I also need access to the back of the printer from the front of the cupboard. So I'm opening up the cupboard door, and I need to be able to get my arm around the back to turn the button on and off and to play with the wires and things at the back. So I need to organize some storage for my filament, which is oriented this way round to give me the clearance that I need to come through here with my arm to turn the printer on and off. And so I thought the best way to do that would be to have a storage solution for the filament, which then had like a cassette style housing, so that it would open up like a kind of drop bucket 1980s style cassette player thing, but large enough for my 3D printer filament. So I've already started modeling this. This is me working out how it's going to work. This is from a previous session. And I got to a point where I was going to rethink the whole thing. I was also thinking as well of connecting it with the Gridfinity ecosystem. So this is me experimenting with some of the Gridfinity kind of models. I don't know if that's just overkill or just me kind of getting into the Gridfinity system because it's novel. Not too sure. Let me just grab my notebook because I made some sketches of what it is I want to do. Clearly not a natural born streamer. I didn't even care what I was going to do today. So yeah, I think what I'm going to do is remodel this setup here where I've got the kind of holder for the cassette style holder for the filament on the inside, and then this kind of foot with the pivot on the outside. I'm going to remodel this so that it's not just a kind of foot, which I then need to, because I was thinking about having sort of spokes that come up so that that connect the feet together and build out a sort of modular what would you call it, kind of strut and node assembly. I was thinking about that kind of setup to be materially efficient, but if I also want to include the Gridfinity setup, I need a top and bottom, and I think I'll make it kind of more box-like. And I can always have holes in the side of the box to make it a bit more efficient. So let's let's go with that idea. Where am I going to start? I seem to remember from last time I was modeling that there was a they're the right distance from each other. Let's move this grid nearer to where I'm working. Let's rotate it. Copy these by the base point. I can then reference the grid. Right, and this should be the baseline. Now, if you don't know what the Gridfinity system is, I would thoroughly recommend just Googling Gridfinity. It's going to take a little bit too long for me to explain. There's an excellent video by the original creator of the open source Gridfinity system. I think it's called Zach something. I can't remember off the top of my head. But it's a really cool system. It's a modular storage system, which is easily 3D printable. Let's check in with the 3D print. Looking pretty good. That first layer is bonding quite well. Grandad will be pleased. Hopefully it doesn't delaminate, but little background fun. I've spent quite a bit of time installing a LED, additional LEDs in my cupboard just so you can have a good well lit stream of my printer. And I think it's looking okay. All right, back to what I was doing. I sort of don't know what I'm doing. So I now want to join all these together. What I might do, you can't see, I don't think you can see what I'm looking at with my other window, so I'm gonna bring this image into Rhino so that you can see it. Maybe later down the line I'll just share my screen entirely. But right now I've just got it on my Rhino window. Alright, so this image here is the reference for the Gridfinity system. So I'm going to use this as a bit of a plan for how I'm going to build out my modular storage container for my 3D printer filament. And if I look at the outer radius of the of this kind of profile, it says it's a 7.5 diameter fillet, which, you know what, that's really annoying. Just I don't know why they've put it in diameter instead of radius. It's normally a radius fillet. So yeah, this is why it's annoying. 7.5 divided by 2 needs to be 3. So hold up, there's too many curves here. Right. I'm going to take a look at one of the models that I imported. So this should just be going straight up from, delete that whole rectangle. Come on, use that reference. Reference, come on. There we go. Ah, this is being really, there we go. There we go. Double check. Not wonky. Often with Rhino, we'll just, you'll think it will be flat, but it's actually wonky, three-dimensional. There we go. Right, fillet. That corner is now matching what I've modeled already. So I've got my kind of base going. The way that I'm going to model this out, if you're used to a sort of SolidWorks parametric modeling workflow, then you'd probably imagine that I'm going to build this out in one big block and start cutting away from the block the holes and things that I need. That's not actually how I'm going to go, because in Rhino, the workflow is a bit different. I'm going to build this out with curves first, and then start to sweep the curves together. I think. Is that the best way to go? Sorry for going silent. I'm just looking at sketches here, trying to reinterpret what I did before, and then come up with a plan. Let's move that up to the top level. $207. So this here is my sort of calculation for how big a space I. So that's that. Center. There we go. So I want to make sure that there's enough clearance. Yeah, it's not sort of locating at the top, so let's just kind of force this. Object tangent, dimension. Two, 3, 6. Now the thing with the gridfinity system, it works in units of 7. So 2, 3, let's round that up to 7 divided by 7 is 33.8. So I need at least 34 units. Let's say 35 to be on the safe side. 35 times 7 is 245. So we're going to move this profile and we're going to copy it. It's late in the evening, I had to multiply. Two, 4, 5. Just copy that, making model fitting. Yeah, looks like there's going to be enough room for that in there. I mean, plenty. Oh, I wonder if I can get away with getting rid of one of these rows. That looks about even. Ballparking. Distance from there to there. Doesn't give me much wall thickness. If I make it a bit larger, then I'll have room for some silica sachets to go in with the filament, help keep it dry. So I'll just live with having quite a lot of space either side. That's fine. Okay, so we're looking kind of. Let's get rid of that for now. Right, I'm gonna start working with layers a bit. So let's have a sub layer and let's call this wireframing. And let's have another sub layer. Call this surfaces. And we're going to move all these. And in fact, I'm going to move this and this and this. Not that. That's a curve. This and this. These are different colors. Ignore them. They're on different layers already. This, that. Those are actually meshes, but who's watching? That. And we're gonna change layer to surfaces. I'm getting annoyed at the button clinking on the desk. This isn't going to turn into an ASMR channel. Move those just away for a little bit. Now all these curves I'm going to put into not change layer, wireframing. Excellent. Zoom selected. Now Now I can turn that on and off and see where I'm modeling and where I'm just building it out. Hopefully that's flat. Yeah, that's where I want it to be, and I expected it to be kind of on the inside of that radius. This is just me kind of working on what that profile is going to be on the inside. And as I draw this, I anticipate that it's all going to be in different places, but I can get back to that. You'll see what I mean when I get to it. Drag over my reference box. No, it's a little bit taller than it is wide. So let's just check what it is. That's 224, 207. Currently taller than it is. I don't think that needs to be quite so high. Circle a little bit in to account for the axle. Offset that to give some tolerance. Oh, I'm looking at the top view. Front. Just ballpark it to be about there. Ballpark that to be clear. Now I want you to give me the tangent. Tangents. Whatever. Distance. That's miles out. Okay, so it's clearly not. That's more like it. 23. So I can actually bring that down a couple units. Remember, with this modular system, it works in height unit 7. So I can probably take off. Let's try taking off 21. Where does that leave me? I think that might just do it. Let's see. Let's see. So what I'm going to start doing now is building out what the internal cassette part is going to look like, what the parameters that are going to look like, and then from there work out again where these holes and pivot points are going to be for the grid approach time. So I'm going to take this outer parameter, I'm going to give it a offset distance of 1 mil as a bit of a tolerance. Inside, so this new inside line will be the kind of maximum space for the cassette, the kind of outside face of the inner cassette. Maximum. Okay, 6 mil. No, that's probably a bit too much. So if I say this is the point of rotation, then I need to look at whether that corner is going to interfere with, oh, hold on a second. No, I need to start this again. Gonna work. So this outer box has a thickness itself. Has a thickness. And it's going to be more than 1 mil. I'd say the wall thickness going to need to be I'd probably want to print this with an 8 mil, a 0.8 mil nozzle for speed and strength, and the 0.8 nozzle, if I just check in Bamboo Studio. Has a line thickness of 0.82. So each wall is going to be 0.82. So if I say it's going to be 2 walls thick, it's at least 1.64. I think 2 walls should be fine. It's going to be load bearing. Three walls. The reason why I say it's going to be load bearing is because I intend to have one unit then be stacked on another unit, right? So we've got this filament and then another one stacked on top. And then although I've only got this much space in my cupboard, I'm intending this to be a modular design that I share online, open source. So I don't know whether the next person is going to add 3, 4, 5 different models on different modules on top. So I'm going to design it to be robust and then streamline it later. So let's say it's 3 walls thick at 0.82 wall thickness. It's 2.46. Offset distance 2.46 inside, and then if I just explode that for a sec, which means turn the box into 4 lines, delete that front line because there's to be a hole in the front, and hang on. Don't strictly need this layer to be that high either. It just needs to be enough. Yeah, let's just model that. Then up by 1. probably all out of alignment now. Let's fly into that. Yeah. So that's fine. And I'll figure out what that top is going to be. But I'll leave that there as a bit of a tolerance for now. So that's going to be the wall thickness of the outer box. Then we offset kind of tolerance, bit of a gap, 1 mil. Curves to offset this, going inwards, that going inwards, and that going inwards. Let's just tidy that up as we go along. So, 2. Now this is where the theoretical outer face of the inner box should be. I've done it again. Circle. Yeah, diameters. Diameter. There we go. In by 6, up by 6. Proportionate. Circle. This is going to check whether there's any interference as it rotates at that point. At the extremes. So this is when I need to what size was this? 225. So the height's going to be 207. Yeah. Ah, I have a view. Hello there. I've only just checked in with the actual stream, you know. Hope you're enjoying this. Yes. Distance. 70. Rectangle 72 by 207. So that's the box. So let's say the box is at the bottom and in its worst case scenario. Which is I guess it's going to be there. Let's copy it and do another test. And we do circle up to that top corner. Let's do another one up to that top. Or that top. Now that's interesting. The further back position is going to clash, but the further forward position can actually get away with it. So now the interesting question is, how much room back do we actually have? Up to that maximum height. Get rid of that. Get rid of that. That is the furthest back position it can go, assuming that is the upper height and this is the center of rotation. That is interesting. This might need a little bit of thought because that also has a wall thickness. And what did we say the wall thickness was going to be? 2.46. Let's offset distance to in trim that up and trim that up. And let's move that. Get rid of these circles because they're using me. That would actually be stronger if it's interfacing with that wall thickness. We can have it on the bottom. Let's move that in by 6. Or in by 8. Just up by 1. So we've got a little bit of intersection there between the axis and the... Oh! No, that's not going to work. Because I want this to be able to flex in and out. Just for the sake of sharing my process a little bit. My filter's not going to work. This little sketch here is showing how the axle is going to flex in and out so that it can clip into the outer case. So it's not going to be possible for me to have the axle along the wall thickness. Has to be clear of that. So let's touch it on and then move it up by 1. Maybe even more than that, 2. That over there. Now this could be a real bother. This could be a real bother. So assuming we've now got the box inside that is not going to work. So it has to go up by 7. This is why we prototype. Selected. Bump by 7. Bump those up by 7. Move that up by 7. That up by 7. And let's see what points on. Connect that up. Points off. Move that up by 7. Now let's give that a try. From this. Oh my, look. Oh, this is okay. Center. There we go. that's the kind of maximum position it could be. Distance. Okay. Okay, fine. So let's say then we offset that by 2.5 outline. No. Okay, within 2 mil. Let's offset it by 2 mil. Then we bring that kind of inner cassette wall up to that offset. Then with that point, let's bring those two down to that point. That's not going to work. Will it? Let's find out. Oh, that's so tight. Less than half a mil clearance. No bueno. Oh, hey, to be fair, I don't necessarily need a top layer to that. In fact, I can't have a top layer to it. How else? How would I get the box out? How would I get the box out? That's good. That's good that I've thought of that. So fine. Let's bring that down to that level. That down to the same level. And we do a circle from there to the worst case scenario, which is there now. And that gives us a clearance of about 4.5 mil, 4.5, 5 mil. Lovely. Does it? Does it? Does it? Does it? Needs to be a front. Let's rethink again. See, this is why there's an iterative process, right? Just watching me go through this iterative problem solving process. Offset 1 mil clearance. That's going to give me some breathing. Then our standard 3 wall thickness is 2.46. The offset from that distance 2.6. Now let's group those together. Distance 0. That'll work for that position. Why is that so huge? Why is that there? That is crossing, but I explode that. Oh, and ungroup. And that. And I say that that. That's now the worst case scenario. Circle. That corner. Clearance. About 3. Perfect. That's much better. That's much better. So I'm going to save that there. Let's take a look at the print. That's coming along really well. I can't see any defects. Yeah, that's looking pretty good. It's now about 9:30. I think I'm going to call it there. Let's check out average view duration, 17 minutes. So someone's been watching for a little while. Well, to the one viewer who's been tuning in, I hope you've had fun. I hope this wasn't too boring just watching me drone on about clearances and wall thicknesses. Yeah, I'm going to sign off for today's stream. Hopefully this is a regular slot.